Okay, the point value I'm not actually sure of right now, but you can, of course, just circle the answers. So you need to show me work for each one of why it's a yes or no. So on this one, if you look, you take the opposite of -5, which is +5, and the 2 is right. So that answer is not correct. The y-intercept being 0, 2, take the 0, plug it in. So I'm going to show my work over here. 3/5, 0 minus 5 squared plus 2. 0 minus 5 is -5. Squared is 25 times 3/5. 3 times 5 is 15, plus 2 is 17. Well, that gives me 0, 17, so that is not the right answer. Let me show the highlighting. Okay, that's for this problem. The graph opens up downward. Well, this number is positive, and since that number is positive, it should be going up. So that is not it. There are two x-intercepts. Okay. For the x-intercept, it needs to be something comma 0. So I'm going to take the 0 and plug it in for y, which is something you guys are used to doing. So 0 equals 3/5 x minus 5 squared plus 2. Subtract 2. Now remember, all you're doing is finding out how many x-intercepts, not what the actual x-intercepts are. I don't like a fraction, so I multiply by 5. -10 equals 3 parentheses x minus 5 squared. Divide by 3. -10 equals x minus 5 squared. Now when you square root this, because of that negative, it means there are no x-intercepts because your answers will be imaginary. So F is in and D is out. Okay. Now, if that negative wasn't there, it doesn't matter that square rooting 10/3 is annoying. There's two possible radicals, square roots. The only way there would be one x-intercept is if I had 0 equals x minus 5. Sorry. Whatever, squared. And when you square root, positive nothing and negative nothing will only lend itself to one answer, okay? If you look down here, the y-intercept is 0, 17. Well, I just showed that above, okay? The end behavior is positive infinity. Well, we said above that it opens up, and if it opens up, the end behavior is positive infinity. Okay. Technically, it's negative infinity here, but when we're talking about the y, I'll accept that. Probably should change it, but we'll worry about that later. Okay, let's go to the next one. Does this open up or down? Because of this negative, it opens down. Show that, and I'm happy. The axis of symmetry, so if I was going to draw my U, the axis of symmetry is what goes through the vertex, so it's the x value of the vertex. If you remember, I said options are that you could factor this, which I'm going to tell you can't factor it. So you're going to do the formula -b over 2a. So identify your a, -1. Your b is -4, and your c is -1. So I'm going to go -b over 2 times a negative and a negative make a positive, 4 over -2, -2. So you found the x value of the vertex, which is x equals -2 for the axis of symmetry. And when it comes to point values, I'm not sure about that yet. This feels like 1. That would feel like 2 points right there, 1 for the x, 1 for the -2. Then what you're going to do is you're going to take that -2 and you're going to plug it in for x. Now I want you to be careful of this because there's a -1 times -2 squared minus 4 times -2, sorry, very bad, -1. Okay, let me zoom that in a little bit. So what I did is I took my -2 and I put it in for x. -2 squared is 4, times -1 is -4. A -4 times a -2 is a positive 8. And then 8 minus 1, 4 minus 1 is 3. Now what I suggest you doing is after you finish this problem, I would graph this in the calculator and go menu trace, graph trace, and make sure your vertex is actually -2, 3. And if it's not, you've got to figure out where you went wrong. Okay? Is it a maximum or a minimum? Well, since it's going down, it's a maximum. Okay? Show me that work, please. x-intercepts. Well, to find the x-intercepts, you need to factor. The problem is I know you can't factor, so you can either solve by completing the square or use the quadratic formula. I'll do the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So therefore, what I'm going to do is I'm going to go, you look at the a's, b's, and c above. So I'm going to go negative of negative 4 plus or minus the square root of 4 squared. I don't put the negative because anytime you square it, it turns positive. Minus 4 times negative 1 times negative 1 all over 2 times negative 1. Now, the issue for me is all of this. So I'm going to take care of all of this before I acknowledge anything else. 4 squared is 16. 4 times 1 is 4. A negative and a negative make a positive and a negative. Okay? So it's the square root of 12. And when I tree it, it's 2 rad 3. So all that lent itself to 2 rad 3. And now I'm going to simplify negative of negative 4 is positive 4. And then 2 times negative 1 is negative 2. So I have two issues here. First issue is all of these are divisible by 2. So 2, 1, 1. But it's also negative, so this should be negative, and that positive turns negative, and that negative turns positive. So your answer for your x-intercepts, x equals, oops, sorry, I'm not ready for that because I have to do the decimal approximation. So I'm going to be looking for this, and then I'm going to look for you to split it. And then let me pause while I get a calculator. So I put them in the calculator. It's kind of hard to see. Negative 2 plus rad 3 rounded to the nearest hundredth is negative 0.27. That's one answer. And then another answer, x equals, I know this is a mess, negative 373. Again, what I encourage you to do, but I don't have time to do it right now, so hopefully I'm correct. I would take this and graph it, and then I would go menu, trace, graph, trace, and then I would see if those are actually the x-intercepts where it touches the x-axis. Okay, the y-intercept, I plug in 0. So I'm going to go negative 0 squared minus 4 times 0 minus 1. Anything times 0, 0 times 0, 0. All I'm left with is negative 1. Show that work, please. The end behavior. Okay, so we know this thing is going down. So that means this is the point negative infinity, positive infinity. And this is positive infinity, negative infinity, okay? So this is towards the right where it's positive, and this is towards the left where it's negative. So as x approaches positive infinity, okay, so as x approaches positive infinity, f of x approaches. As x approaches negative infinity, f of x approaches. So if you look, oops, that should be negative infinity, sorry. Both of them are going down, so negative infinity. Okay? If both of them were going up, it would be positive infinity, but everything else here would be exactly the same. The intervals. Okay, so I'm going to use this a little bit. The vertex is crucial. We figured out the vertex was negative 2, 3. So when you're doing the intervals, you're focusing on the x-axis, okay? So the intervals, you're saying from here to here. So from negative infinity to negative 2, it's increasing. And then from negative 2 to positive infinity, it's decreasing. Not a straight decrease. Okay. The domain for every quadratic is all real numbers, which is negative infinity to positive infinity. Make sure you're doing an interval and set notation. The range has a limit. If it's going up, it's greater than, but since this is going down, it's less than. And you just find the y value of the vertex, which was 3. Okay. Obviously, that's a lot of work, so it's worth a lot of points. If you feel like you don't have enough space here, you will make a little star and show me work. All right, solve for x, square root, x plus 7 equals plus or minus 14 minus 7, x equals negative 7 plus 14, negative 7 minus 14, So x equals 7, x equals negative 21. Let's check. 7 plus 7 is 14, squared is 196. Negative 21 plus 7, negative 14, squared, 196. All right, I always am going to try to factor, and I actually can. Two numbers that multiply to get to 12 but add to 8, set it equal to 0. Now, if I have time, I'm going to graph it. And if I graph it and I go menu, trace, graph, trace, those are my x-intercepts. For this one, I could store values for x, but I think you guys know how to do this in your head. Page 1, done.